My name is Dominik Süß. I'm senior engineer at Adobe, working on the cloud service since its very early days, like basically proof of concept. And I'm working currently in the foundation core services team, working on the platform development experience. And this is mostly about functional, but more non-functional aspects of the build pipeline. So I guess the majority of you are consumers of that pipeline, so you once in a while deploy something towards the cloud. So therefore you probably have experienced a few of the pain points that we try to tackle over time. And in this talk, the part of providing you guidance how to do stuff, that's mostly about kind of sharing with you stuff that is about to change slightly so that you have orientation as soon as those changes are being rolled out. It is just a 20-minute talk, so therefore I can't go into the details too much, but I try to go through the history that we have behind the cloud service, how we got where we are today, what you know. Then I will go into basically the roadblocks that we were hitting and why we had to change some stuff. And last but not least, look a bit into what is changing now and what hopefully will be changing over time and what our plans are in the near future. So let's start with the value proposition that we had to have when we were moving towards the cloud. So the point was we were taking over operational responsibility there. And operational responsibility in scale. So you know AEMaaCS. AEMaaCS had some limitations on kind of like, because you had like each and every setup was individually like that, and that could not scale endlessly because of the amount of customers that could be served by an individual engineer from the AEMaaCS team. So what we did try to set up is a pipeline that is performant, scalable, resilient, and last but not least, deterministic. Like this is a crucial thing for us. If we want to automate something, it needs to be reliably passing or failing, and things need to be reproducible. So starting with that, we started with, we start with a POC where we did basically say, like, this should still be AM. It should be the same product. Therefore, we had to look into how we can refactor all of that. And the first step was separating out an immutable head, an application head that we could swap out. So therefore, we can have something like blue-green deployments. And that meant we had a complete separation of content and apps. What sounds quite natural now, as you know that your blips and apps are stable and are not changing at runtime, was not back then. And it took quite a while to properly align stuff, move some stuff that had to be swapped with a deployment into this area and shift some stuff out that was modified at runtime. Then we did start with a POC for Dockerization, making sure that we had a framework on common technology to be able to run all that, operate that, automate the flows, and in the end came up with a POC that was running on Kubernetes that was working and that allowed us to do blue-green deployments. And that's when the decision was made, okay, that's ready for starting with the beta project. So when starting with that beta project and first customers, we did learn about a few things that had to be changed to mature that to a point where we can go GA. So what was invented back then was basically the feature launcher and the feature model that you probably know from the Slink project, if you follow that, which allows us to have a deterministic launch and to be able to build all of that at scale and roll that out. There was a process which uses the Cloud Manager for having the deployment pipeline, and the second step was the build image step that was introduced that basically uses a base image of AM, of that concrete version, and layers the customer application and everything that's immutable on top of that. and then distribute to the concrete environments through those images. We also had to add a mutable content job because, yeah, the separation of apps and libs as immutable node store does sound pretty nice. And at deployment, we just wanted to change that. But then we have some features like editable templates that allow to change stuff at runtime. And we got requests that people said, OK, we want to make sure that when we are rolling out a version of our code, we want to perform certain modifications. So therefore, the mutable content job was added to have post-deployment modifications to the mutable content. That was a necessary step. I still recommend, if you can avoid to depend on that, try to avoid it, because it's always kind of like that is where the whole kind of blue-green deployment contract starts to get a bit fuzzy and rollback scenarios can get hairy. So the last but very important step was moving out certain logic into external shared services. You probably know about the asset compute service. That was a huge chunk, processing not happening on the Java runtime, but in external services. Replication is the other quite popular one. And there are a lot of smaller tasks and services, specifically on the operational side, that have been moved out of the runtime and run in dedicated services that take care of that. And partially multi-tenant services, and this is just to make sure that we have an operational layer that scales to what we need. So now we had to mature the pipeline because there were still problems with regards to the value proposition. And that meant for speeding up stuff, we had to shift as much of the pre-compilation or pre-processing of the product outside of the customer pipeline. And we improved the product pipeline. Basically, the base image was far better prepared, and that reduced the time that you were seeing for those customer pipelines quite significantly. We also introduced a custom Kubernetes operator that allowed us to optimize the flow of deployment behind the scenes. So if you know Helm and like how the deployment typically work, it's a quite linear flow of doing things and deploying the stuff with initialization. And this operator that we have running behind the scene is basically taking that and is able to optimize the flow to already start stuff up before it is actually being consumed. And therefore also make sure that we have a smoother deployment experience and have an easier time on scaling out, enabled us to establish things like secondary regions, geolocation, stuff that is being synchronized through that operator. And for the build image step that I did talk about before, we did also try to optimize that as good as we can by reducing what is being started up there. Initially, it was starting up a full AEM instance as it is, the full model that of the customer code and so on, just to install the content and then being able to use that state. But, and I didn't start the timer. Great. Yeah, but what that led to is that we had to wait for that. Customer logic was partially stuck and consuming a lot of time. And now we have a minimal startup. So only what's required to be able to install packages is being started up in that step. And that also reduced that time. And we did try to establish as many guardrails as we could about stuff that can be done wrong, misusages, detecting error scenarios, and whenever we got failures, we did try to establish corresponding guardrails. So where are we standing right now? This is about hitting roadblocks. Product updates require running CM pipeline execution. As you probably know, Cloud Manager is a completely different stack. It's a multi-tenant service that is running on various microservices, and those microservices also do not endlessly scale. One of those is also the part that it is using the Azure ACR service to run the build image step. That's an Azure service that's being used, which is mostly a black box, and is going in the direction of a function as a service approach. You just pass the Docker file, it processes it, and eventually you get the result. You can control one thing, that is the amount of CPUs. Everything else is kind of like magically happening behind the scenes, which works in almost all times. But when something is getting stuck or is slow, you have no way of introspecting, you have no way of seeing what is going wrong. There's, like, basically we were not operating it, therefore we could not introspect it. The Docker registries, I said, like, we are just this little customer stuff that we're building on top. That's actually not entirely true, because yes, we build on top of the base repository, so that's already pre-built in the product image, but still, everything that this image is touching does binary modifications, and the Docker layer in the end is getting pretty big. So we always had quite huge layers. For some customers, that was really multiple gigabytes, 3, 4, 5 gigabytes of Docker layer, and that's for each and every execution. So every time something is coming in, a new Docker layer is being created, and that is in one big shared Docker registry. And that was exploding. We were close to hitting the limits, and on certain, like the internal stage clusters, we were hitting the limits, and like hell break loose because we had to react. That was being scaled out. That is still working, but it did show us there is a hard limit in terms of what those shared services can do for us. Also, we had the problem that this ACR service is something you've started, and eventually you get the result and you get the logs back. But until that happens, you have no way of seeing if that is currently on the way of failing or something like that. And for a lot of scenarios, how stuff is failing, as you know, for starting up AEM, and stuff is trying to resolve and trying, and eventually it ends with a timeout. And that meant that often enough, people had to wait 1 hour just to learn that they had a little typo in there. That's not the most pleasant experience, and also prolongs your development cycles. The reuse between those runs were also quite limited because, yeah, we're always starting to build up from the base layer. So anything that was built in those Docker images and produced for those could not be reused in a subsequent run, so even if there was no change in this area. So that were our roadblocks, and from our objectives or the value proposition, we had something that was resilient. We had something that was deterministic. Performant, if everything was working fine, if you had taken care of something that builds locally, also builds quite fast, it could be fast, but often enough it was not. And scalable, as I said, like, yeah, we were about to hit hard roadblocks there and hard limits, and it was quite some effort just to kind of build some bridging solutions even to be able to run that as it is right now. So what are we doing? We are remodeling the pipeline. Coarse-grained, we move everything that we can pre-process towards the build step. So basically, we instead of ending with the Maven build as you do locally, there's a bit more of an execution that happens afterwards in the Cloud Manager pipeline. And that's something where we did work together with the Cloud Manager team to make that happen. And that also allows us to improve the reusability, because we basically at that time can do things like extract content hashes or identify certain things that have been unmodified so we can reuse them. The second thing is everything that comes to product integration moves back to the deployment time. So essentially, we are no longer requiring the build image step, but we are starting up at deployment time with something that's called transform job. That is basically doing the product integration, then saving that back into a blob store, and therefore we can consume that when we are starting up the individual instances. And that's what I have here, like a small little infographic about what we had before. In the build image step, before it was starting to build performing the Maven build, ending with the content package. That's what you also did locally. That was stored to a blob storage, then being passed into build image step, along with the AEM base image, which is a concrete version of AEM that this was merged on top of. Then we were running the Sling CP converter, or basically that we have a bit more like a rapid tool which does a bit more of that. That is basically stripping out a lot of things and producing basically a feature model file. But because we can't work with those nested packages internally, but we have to have a flat list of packages. We have to have all the metadata available, and that's being done in there. Then this is being merged with the corresponding model from the AEM from the AEM base image, and we produced an author image and a publish image, 2 images for each run, and those ones were then being passed into the deployment phase. If index change, like every time it did start the indexing job was consuming the customer image, reading the index definitions, comparing those to the ones that were on the mutable content, and then deciding if an indexing run was happening. But it had to load the complete custom image to be able to decide if it had to skip. So what we do now is looking a bit more like that. You see that the build image step has been dropped. Now, after the content package is being built, the output that we are producing actually is running through something that you will see is the convert, merge, analyze process, which already produces the files that I said before. Not all of them are yet produced, so pre-compilation, there's still something that we will be working on in the future to optimize that, but the majority, like at least the stuff that was happening before in the build image step, is being converted like that, then stored not to a Docker registry, because we don't have a Docker build, but into a blob store, along with the metadata file. That one is then starting the deployment phase. The operator is then picking up first the index definitions, because what we do now is we extract the index definitions already at that time. Therefore, we only have to pass this small little JSON file with all the index definitions towards the job, which allows it to either skip and fast or then perform the indexing without having to load the immutable node store. After that, if something has been changing, so the transform job is being started, and that one is basically then performing the actual integration. Everything that's happening in this phase is just running against the SDK jar. So basically only the APIs and everything that you can see, that you can download as our surface is being consumed and evaluated against. So every metadata that to check for that version. The reason for that is if we later on do a new product version deployment, we want to reuse the result. So therefore we cannot do the product integration at that point. And since API, we make sure that we have backward compatibility on the API level, the result that was produced against an older SDK will still be able to be integrated at a later state against the newer version. Transform job integrates that, stores that into a blob store, and whenever an author or a publish environment is being launched, the pod, the Kubernetes pod, is first initializing by downloading those artifacts, which are basically only the diff, because as I said, like it's just the additional segments and the additional client libs. Everything that from the product is still being used from the image. That one is being mounted in. Basically, those are just symlinks into the file system. So therefore, for the instance, and in the end starting up, it looks exactly as it was before. And therefore, the startup should work as it was before. So, and due to time, I have to skip my little demo. There's just one little thing that I want to make sure that you understand. The build image step will still be visible for the reason of what was it? Building the, help me out. UI tests and another one. Dispatcher configuration. If you don't have a web tier pipeline, it builds the dispatcher configuration in the build image step, but which no longer has something to do with the AEM deployments, like the customer images before. But this only takes a few seconds, 20 to 30 seconds, as far as I remember, and then it is going into the deployment phase. The majority of issues that you were seeing in this log, you will see in the build log. Only the ones that are happening at runtime, like basically in the ones that were previously when installing packages, concrete packages, and cannot be called by the static analyzers or by the analyzers in the first phase. Only those ones will end up in the transform job log. And for the demos that I had, I did try to get a demo scenario for failing in the transform job, and I did fail. Reason for that is pretty simple. We had so many, like as we were adding kind of the cross checks for the various things that could be failing into the analyzers ahead of time, basically everything is now failing in the build step that was previously failing when starting up. And I just couldn't, in the time being, come up with a scenario. The demo scenario that had initially had been fixed in the meanwhile, so that we fail early. And but still, there is a section. If you search for transform job.log in that in the deployment log, you will get that section. And a quick reminder: that's the same is true today. Keep in mind, you will not see the instance themselves starting up in the deployment log. Whenever something is failing at that point, you have to use the Cloud Manager CLI, like the AIO-CM CLI to consume the logs of the running instances, because there you will see anything that is failing at that time. Something like if you have misconfigured environment variables that's specific to an environment, because everything up to that point is independent from the specific environment. Changes that you have for yourself is, I guess, little changes. It's moving around where you consume the logs that are relevant to you. So stuff is moving into the build phase. Some stuff is moving into the deploy phase. Mostly build phase is relevant for you from the logs. We did try to optimize the log output for the transform job, and we will be looking into optimizing the log for what is happening in the build step and reducing that. We already did kind of like make sure that you probably have seen those huge client lib compilation errors, because it always kind of, because of the compression, was always outputting the whole file and dumping that to you. We managed to fix that just recently. And we will be looking into ways to optimize that a bit more. And that's also where we depend on you, that you report stuff back to us where you say, like, this is not a decent experience within that pipeline. Outlook. So what this means is basically we can scale better. We can do pipeline-less product upgrades. We can do product upgrades without colliding with the deployments that you are invoking. And this is something also about the amount of images that have to be generated. We can have optimizations for the skip and reuse logic. That's where we are already looking at where a few things we already have done. So we have some certain timing improvements. So that is something that you probably already can feel, but there's more that we can do. Resource usage, we can throw more resources at it. And last but not least, we try to iteratively improve and depend on your feedback. And that's it.
Thank you, Dominik. We have just time for one question. So we talked about like performance improvement with like the new features, and how much time did we gain average?
So at the moment, like it depends. The bigger the project, the more gain we have seen. At the moment, the customers that we are running on that already, we've seen a roughly 10 to 20% timing gain. For big projects, there is significantly more that we can win from that. But the primary goal was first to eliminate the roadblocks and then look into the corresponding optimizations. As I said, the escape and reuse across, like from execution to execution, this is something we still have to lift, and then it depends on how much you're changing. If you're the less you're changing, if you're only changing client libs, we probably can identify that and only take care of this section. If you only were so this is something that we can do then.
All right. Dominik also will be available during the playground session at the AEM DevOps table, so you can raise more questions there. Thank you, Dominik.
You're welcome. Thanks.